Hello, my name is Dr. Kyle Talchin. I'm a mathematician. Going to do a series of videos on uh, what I would consider foundations for math. This is going to be highly non-standard foundations, not odd math, but math not as you would typically taught. Um, Hoping to make this a pretty long-running series and cover a fair bit of ground actually. So this video is just meant to give a quick overview of what my motivation is and some of the ideas behind this, and then give a sense of the arc I'm hoping to hit if I succeed. So motivation for this. So first of all, and primarily, the aim of this is to develop mathematical vision, intuition, and taste. Um, I want people to actually have a sense of what math is. So this is aimed. The motivation for it is, say you're a student coming out of high school, decent math background, doesn't have to be phenomenal. Um, if you really wanted to see what math was, how would you do it? Or what would I show people at least? And that's what I'm going to try and do here. The audience is meant to be for any undergraduate who's interested. I think the material will be interesting for people right out of high school. I think high schoolers could find it interesting. I think decently advanced undergraduates. I think graduate students of certain sorts, certainly in other fields, but even in math. Um, and especially, I think people like math teachers. I would be really happy if we end up having some math teachers who find this interesting to get under the hood, as it were. All right, so stylistic choices. I'm going to make some rather particular choices here. Um, First of all, I am going to take a rising C approach in everything I'm doing. The rising C approach, so I'm taking that from a Grothendieck quote. I think it's actually from a translation by Colin McClarty, which is he's a Case Western professor where I got my PhD. Um, the idea, though, refers to building stuff up systematically and slowly and making everything obvious and taking your time, not taking your time for its own sake, but not making things obscure or opaque. Um, Maybe we can get to the analogy at some point, but I'm going to build everything up, and I'm going to go in the right order, and I'm going to prefer long-term power over short-term tricks. So there's not going to be a lot of calculations where it's where the heck did that come from? Everything's going to build bit by bit and show you where we're going. Um, going to follow a approach where pretty consistently where every time we encounter a situation, I'm going to start with what's the motivation here? What are we trying to do? Usually, then, because of the motivation we have coming into it, there's going to be some simple number of constraints. Sometimes it's one, sometimes it's several. And then, usually, what happens, at least for pretty much all the material that I'm going to talk about here, and I think for a lot of mathematics, frankly, well, once you have the proper motivation for the situation, you understand which constraints are natural, well, then the mathematics is sort of what emerges and what remains. And so I'm going to talk a lot about structure, and structure is really going to be the stuff that survives these different constraints. That's going to get to trying to help form the intuition. Um, this is going to be a very wide but admittedly shallow exposure. So in a minute, I'll run through the subjects we're going to get to. This is in no way a proper course in any of the many things I'm hoping to touch on. It will be enough to get started, and it will help people understand how a lot of different things fit together. And it's meant to set you up for then starting a deeper study of these things. So please don't think that going through this, you're going to get a proper course in category theory or in topology or in homological algebra or something. But we're going to touch on a bunch of things, and you'll have far better awareness of the overall landscape after this, I hope. Um, One thing that'll be very apparent as I get into this is I take the opinion that math is very much about relationships. Everything I'm going to do is going to be category theory native. That's not because I'm a category theorist per se. I just think it's the best language to express a lot of the most fundamental things for math. At least it's the one I find the most powerful, and it's the one I would choose to teach people, which is what I'm doing. And finally, one that won't matter too much in this course, but I do care a bunch about uh, properly encoding geometry. So that won't be so much this course, but I think in the what I hope to be some successor videos on calculus, proper calculus course, and linear algebra. There'll be a lot more Clifford algebras, geometric algebras, whichever language you like. But I think those are hugely important in a I have no idea why they are so missing from standard curriculum, but they absolutely should be taught in any calculus course, in any linear algebra course, and that's how I'm hoping to teach them. All right, so motivation. So after this, this is meant to be a preparatory series. It's if I get through it, I'm hoping to. It will be this series will be very long, but it will give the proper foundation, in my view, whatever proper means. That's not a well-defined term, but it's whatever is in my head for proper. It will give a proper foundation for a good calculus course, probability, and linear algebra. Again, those will be both standard-ish, but also highly non-standard, similar to this course, which will be there's no non-standard mathematics in here. Everything is not the newest things I'm going to teach are going to be 50, 70 years old, but the idea of putting them together in this order and in a course like this is, I think, not common, and that's what will be true if I ever get to making those courses. All right, so what am I hoping to cover here? So I think of this as having a bunch of big blocks that I want to cover, and then inside of each block, there's going to be a number of series. So the first series I'm going to get into is a basic series. This is just to get rolling and fix some language and get people enough to start the course proper. So the very first series I'll do is on is just going to be these key examples. We'll just talk about the common number systems. We'll do the hierarchy from the naturals to the integers, the rationals, reals. I'll talk about why the complex numbers I don't think actually belong in that canonical hierarchy. Talk about why that is, do a little bit of Rn and spaces of matrices, because I think those are really key examples. That will not be that series of videos won't be the proper course. They'll just be so we have a supply of examples as we start doing the course itself. In the process of that, we'll do a little bit on sets and functions because we need to just use it for the examples. Then I'm going to have a series or two on just math statements and arguments. So I'll do a number of videos on how do you read math, what's some simple notation, and how do arguments work. It'll be not rigorous, but so that you can actually read proofs and make proofs and that sort of thing. And then I'll have one or two series on sort of bare bones category theory, just enough category theory to get us started, because then I'm going to go into the foundational category of set, and we're going to spend a bunch of time learning how to think in terms of relationships, in terms of maps, practice this sort of motivation, constraint, emergent structure paradigm, and we'll spend a bunch of time in set, and we'll get through common things. We'll actually end up building the number systems properly. We'll talk about things like relations, and we'll do categorical things like products. We'll close that out with pullbacks and things like that. I say 15 series here, or like I say 5 series here, because I'm thinking in terms of, if I think of this in book form, I've got these big blocks in the book, and I got a bunch of chapters, and each chapter's got sections, and I'm thinking roughly each video is going to be basically the equivalent of a section, just to make timing work right. So each series is essentially a chapter, but it'll be just a number of videos on a given topic, building it up from scratch, and then a number of series together build up to a block. Just that's how I'm thinking about these. Okay, so after we spend a bunch of time on set, then I'm going to show how to actually model logic within the category set, which will be a really good just practice. We'll get to see some pretty neat categorical things and how they come out naturally, and that'll actually be a lot of fun. Even more fun then, we'll spend a little bit of time, I hope to spend a little bit of time, then deriving topology as a form of logic and show that actually topology comes out naturally. It's not some weird thing that you impose with open sets. Like there's a reason why we do open sets. It's a type of logical construction. So we'll show that and do the basics, just a little bit of the basics of topology, enough to talk about the category top and maybe do a few things like quotient topologies, but we won't get very far. From there, do what I'm calling the essential zoology of algebra. So that's going to be long. That'll be the biggest part of this course. And so for that, I'm going to build up bit by bit from the most basic structures to more complex ones. So the core of that will be the groups to rings, fields, and R modules. Importantly, I'm going to define all those things categorically. So we're actually going to start. It's funny because I've in a lot of intro category theory books, they'll say if your mathematical education could be flipped, you could take as a definition that a group is a one object category where every morphism is an isomorphism. Um, and that's actually what I'm going to do. I'm going to actually define all these structures categorically first, because I actually think it's the more natural way to do it. It's a historical accident that we're not. So that will be fun, and that'll get again. This is where I say this will not be a thorough introduction to anything. We're going to just scratch the surface, give you enough to get a little traction, but then move on to the next thing. We're not. This isn't a group course or a ring course or any of that. Um, then we're going to really dive into what's probably most important for a lot of practical purposes, which is then we'll focus in on vector spaces and we'll do some linear algebra. That is there in particular to set us up for the other thing, in addition to the topology that I'm most excited for, which is to then do a proper discussion of extensions of linear algebra. So I'm gonna show how to, and then using a bunch of this categorical stuff we would have built up until this point, talk about tensor algebras, then show how you go to exterior algebras, then show how you go to Clifford algebras. And none of this is accidental. I want all these things at hand because these are essential, for instance, to do calculus well. And so at least what I consider well. So I'm going to do what I hope to be proper series of videos building all these up, showing how they're natural, not having them be confusing as hell as they usually are. And that'll be probably the high point of this course. And then we'll close out. We will do a little bit of homological algebra. That again is mostly preparation for some calculus and talking about chains and cochains. So we'll spend a number of some series on that. And then finally, there probably will be some categorical loose ends. I don't know quite how I'll sprinkle it in, but I may end up doing some adjoint functor theorems or talk about higher category theory. Not to actually get into it, but just talk about how what we've shown so far, maybe talk about like the category cat and then say what you could extend it to and these sorts of things. So that's where I'm hoping to go to. I got no clue. It's perhaps a little foolish up front to call my shot, but this is where I'm hoping to go to. Now, if each series is roughly a chapter, I've got, in my outline, maybe roughly 10 videos per series. I don't know. This is gonna. If I succeed, this will run into some number of hundreds of videos. I'm gonna try and keep them short, keep them in the 8 to 15 minute range because I think it gets too tedious otherwise. And then people, if they want one little subject, they can do it. But if they want to see how things build, and they can do so. Maybe in the future I will actually make a website around this. There is some hope maybe to write a book around this, but I'm basically using the videos as a test case, and we'll see if I get any traction actually making videos, and then after that, if people actually watch them. But all right, so hope you enjoyed this. More to come. Probably next video will be a overview of that first, just the basic number systems, and we'll start talking about the progression from the naturals up to complex numbers and matrices and that. All right, that's all for now. Take care.